Okay, so this is the first medium hard question from the second edition of Statistical Rethinking. For Chapter 6, and if you're going to run the code that I'm using, then you need to use these first two blocks here to install and load the rethinking package. So let's get into it. Okay, so earlier in the chapter, in fact on page 186, this DAG is presented, and McElrath, I don't know which way to say it, he looks at this DAG and he analyzes the number of paths that go from X to Y, right? So obviously there's the direct path, but for instance, there's another path that goes from X to U to A to C to Y, and there's a few more in there that you could, if you hunted, or as I would encourage you to actually read that part of the chapter and go through the exercise on this DAG. Okay. Now we are being asked to modify this DAG by adding an additional variable, V, that is a cause of both C and Y. Okay. So we're going to do that, and just to point out that there's one novel thing about this DAG than anything that we've encountered in these videos, and that's this circle around this variable right here, around this variable U. And when there's a circle, that's usually meant to denote that that variable is unobserved. So while we posit that that variable exists in reality, it's not present in the data set. Okay, and the variable that we are including is going to be unobserved. All right. So we're going to build that DAG, and we're going to try to count the number of paths that exist between X and Y, decide which ones we need to try to account for. In other words, the non-causal paths that are open, and how we could close down any of those open paths that are screwing up our estimate of the effect of X on Y. Okay, so first I'm just going to build the new DAG according to those instructions. So I need the DAGity package, and so I'm going to call this the DAG 6.1 mod for modified, because this is right from the chapter with the modification. So right here, this part, this is the DAG from the chapter, and now I'm adding an unobserved variable V, and V is a cause of both C and Y. Okay, and so when I go through and I draw this DAG, okay, not a terrible replication, a little bit spread out, but it's the same DAG, and with the addition of my new unobserved variable called V, affecting both C and Y as per the instructions. Okay, so now we need to count the number of paths that from X to Y. Okay, so let's do that, and I've listed them here, but obviously we have the direct path, X to Y, and that's the one it's this arrow, it's the value of this arrow that we're trying to estimate, but it's potentially screwed up by everything else happening in the DAG. Okay, so the next one that I have listed here is that I'm going to go from X to U to A to C to Y. Okay, notice that we can go against arrows, that's fine. Okay, association flows in either direction with these arrows. All right, so we have that one. Okay. We have X to U to A to C to V to Y. Okay, in this case, notice that when we're counting these paths, we've created a collider. By adding V, we've created a collider on C, but when we're just counting paths, we're going to count that as a path, even though that is actually a closed path. Okay, that's fine. So then the next one we have is we go from X to U to B to C to Y, and then X to U to B to C to V to Y. Okay, so you can look at all of those right here, and just to slow it down for yourself if you need to. So we have a total of 5 paths, and we notice that 2 of them are open. The direct path, and that's the one we want to know about, but also the second one that we listed, where we go from X to U to A to C to Y. Okay, that one is still open, and so we need to close that. Just a comment on that. I think that this can be a little bit confusing. DAGs in general, as simple as they look, they can become very confusing when you try to think your way through these things. I said that there's a collider here on C, and colliders are closed, and so you think, well, how shouldn't that path be closed? Well, it's only the path that goes from A to V is closed, right? because that's where the collider is between A and V, okay? So, but in the context of A and Y, C is not acting as a collider, it's acting as a mediator, okay? And so that path remains open. So, okay. So, so we have two paths, and we want just the X to Y open. We want to close this one that goes from X, U, A, C, Y. And so we need to figure out what we need to condition on in order to close this non-causal pathway. So let's go through each of these variables one at a time and see which one makes, or there might be more than one, which ones make sense to try to condition on and therefore block the path. Okay, so we'll start here with U. So U would be a great one to condition on, right? So so if this entire pathway starts with U, and if I could block U, then I would block this entire pathway. The problem is that U is unobserved, right? So we have no data to condition on, so we can't condition on U. But had we had data on it, it would be great to condition on. It would block the entire path. So we have to keep going. We could go up to A, okay? And it looks like A would also be another viable candidate to try to block, okay? So if I condition on A, I stop this flow of association, and there doesn't seem to be any negative consequences from doing so. So A would be a good candidate. And now let's think about C. So I want to block the path that goes from U, A, C, Y. And so by conditioning on C, I do block the path from A to Y. The problem is that because C is a collider between A and V, I then open up the path from A to C to V to Y. So even though I've closed down one path, I incidentally open up another path. So that means that the only variable that we can condition on, besides X, is A. A is the only one that should close down this non-causal pathway. Okay? And so that means that our regression should look something like the following. So obviously I'm trying to estimate the effect of X, so that has to be in there. Okay? But then I also need to condition on A, so I need to have a term for A there. Okay, so that was fine, and it's fun to think through these things, especially to know to understand to see if you can understand your system. But like I said, these DAGs, they do get confusing, surprisingly confusing, and so luckily the DAGity package once again has all sorts of tools that can help us. Well, that will just give us answers, okay? And here, the command that we want is the adjustment set. Oh, okay, why is it adjustment sets? It's because in this regression, I am adjusting by, the variables that I'm using to get the estimate that I want, kind of these second-hand variables, I'll call it, or the ones that are just meant to block everything else. We call those adjustment sets. I need to adjust my regression formula in order to get the estimate that I want, though. So anyway, so I need to use the adjustment sets for this DAG, and I need the exposure, or so X is my exposure, right? And for outcome Y, right? And so in other words, so this is going to spit out what variables I need to condition on in this in order to estimate the effect of X on Y. Okay? And so when I do this, it says A. A is the adjustment set, so I need to condition on A, which confirms our answer. Okay, thanks.